Can you solve this algebra challenge? Here's the question. Given this equation, x squared plus 3x plus 7 equals 6 over x squared plus 3x plus 2, where x is a real number, then the goal, of course, is to solve for the value or values of x that satisfies this equation. Now, pause this video right now and see if you can answer this question, because I will show you the solution in 3, 2, 1. Alright, so given this equation, the goal is to find the value or values of x that satisfies this equation. Alright, now, notice in this equation, we have x squared plus 3x plus 2, and we have x squared plus 3x is the same thing, and this 7, we can break this 7 as 2 plus 5. And now, notice we have two same expression, and if we have two same expression, the trick is to replace this with another variable, and now let's call this as t. So our equation now becomes t plus 5 equals 6 over t. Now, as you can see, this looks simple than the original equation. Alright, so now let's focus on this equation, t plus 5 equals 6 over t. What we're going to do here is to multiply both sides by t. So t squared plus 5t equals 6. Then, subtract 6 on both sides or equate this to 0. And now, let's factor this quadratic equation. Notice that negative 6 is negative 1 times 6, and negative 1 plus 6 will give us positive 5. So the factored form of t squared plus 5t minus 6 simply equal to t plus 6 multiplied by t minus 1. Now, since it is equal to 0, using the 0 property, we can say that t plus 6 equals 0, or t minus 1 equals 0. Now, on the first case, if we solve for the value of t equals negative 6, and on the second case, we have t equals 1. Now, we found two possible cases wherein this t equals negative 6 and the other t equals 1. And we know the value of t is x squared plus 3x plus 2. So, in the first case, we have x squared plus 3x plus 2 equals negative 6. And in the second case, we have x squared plus 3x plus 2 equals 1. Now, let's solve for the values of x in these two cases. So, the first one, if we add 6 on both sides, we have x squared plus 3x plus 8 equals 0. And the second one, if we subtract 1 on both sides, we have x squared plus 3x plus 1 equals 0. Now, x is a real number. So, let's check first the discriminant of these two quadratic equations. By the way, the discriminant is equal to b squared minus 4ac. Now, b here is the coefficient of x, which is 3, and a is the coefficient of x squared, which is 1, and c is 8. So, let's replace b, a, and c. Now, simplifying this, we have negative 23. Now, it follows, since the discriminant is a negative, we don't have any real solution for this quadratic equation. Since we want real solution, so we need to disregard this first case. Now, how about on the second case? So, let's get the discriminant. Let's replace b, a, and c. And if we simplify this, we have equal to 5. Since 5 is a positive number, therefore, we found real solution in this quadratic equation. So, let's focus on this quadratic equation. Since it is not factorable, so we will use the quadratic formula. Negative b plus or minus square root of b squared minus 4ac, or the discriminant, all over 2a. Now, let's replace all a with 1, all b with 3, and all c with 1. Now, let's simplify. 3 squared is 9 minus 4 is 5. So, we have x equals negative 3 plus or minus square root of 5 all over 2. We found two real value of x that satisfies this equation. We have positive version and the negative version. And of course, we need to double check if this answer is correct or really satisfies the given equation. But instead of replacing this variable x with this value, we will use an online calculator. We have Wolfram Alpha. You can also use this online platform to double check your answers, like we did. So this is the Wolfram Alpha. Just type in on the Google search Wolfram Alpha. Then type in this part, given your equation, and then hit equal sign, then this platform will give you the answer to your question. And as you can see, we have two real solutions. This is the value that we get. And we also have complex solution. And now, as you can see, the values that we get is these two values. Therefore, the real value of x that satisfies this equation are x equals negative 3 plus square root of 5 over 2. And the other one is negative 3 minus square root of 5 all over 2. And as always, we are done.